So one of the big data types that comes up, especially in some fields like finance or economics, is time series data. So here we're tracking the value or values of some items over time, and dealing with those timestamps or those dates. It can be complicated, and this is something we deal with so often in real life that we don't even realize the kind of tricky arithmetic that we're doing. But like for instance, if you add 60 minutes to 60 minutes, you get 120 minutes, yes, but you also get 2 hours, and that is kind of strange. It's in fact it's very strange, but we just don't think about it. We have these very odd, there are 60 seconds in a minute, 60 minutes in an hour, but 24 hours in a day, and then 365 days in a year, and it's just there are all these different bases running around, and so the arithmetic that we need to deal with these things very consistently is actually kind of strange. So most programming languages and platforms have inbuilt functions to do this, and so we're going to do an example where we get it wrong, or not wrong, but we do it non-optimally, and see kind of why we need these built-in functions, and then we'll do a case with the built-in functions and see how well it works. So let's go to our new sheet, and let's ask ourselves a question about authors and their publication dates. So one of the questions I had when I started looking at this data set is, how long does it take for an author to get published? How old are they when their first book gets published? Do they have to wait until later in life? Do people get published relatively early in life? Are there different groups? It's just kind of an interesting question in general. So let's make a new calculated field called author age at publication. And we're going to do this the naive way first. So if I was going to do this naively, I would just say publication date minus the author birth date. So publication date is coming from edition and birthday is coming from author. And I would just assume that because both of these are dates, that Tableau would know right off the bat how to do the subtraction, and it wouldn't be an issue. So notice I'm not getting an error. The calculation is valid. And so I'm just going to hit OK. So let's make a little table that is author last name on our rows. And I don't actually want to visualize the data. I just want to see it. So I'm just going to make it into a little text table. And to do that, I need to put both of them in rows and then change this one to discrete so I can see it. So for instance, Antrim's age at publication was 16,185. What the heck are the units here? Is that days? Is that seconds? I think it's probably days, but I actually don't know. And Tableau is not being clear about what it means here. There's something strange going on, and I don't know. You need to be more careful. So how do we do this? Let's go back to our author age and edit this thing. So the subtraction, I think, does do days, but we can be more specific. So if we use date diff, which is one of these built-in functions, it is more specific about what you want. So for instance, you say, do I want to measure this date difference in years, months, days, whatever, and then the start date of the period and the end date. So for us, we want to measure this in years. Our start date now is going to be the author's birthday. That's when the clock starts ticking, and the clock stops ticking or ends its ticking on the publication date. And if we go ahead and run this thing, notice these make a lot more sense. So I have 44 years here for Antrim. What's up with Barnhart? So if Barnhart's written multiple books and we're summing the author age of publication, we're in trouble. So this is an aggregation problem. We actually need to change the level of aggregation here from sum to average. Now this is the average across all of Barnhart's books. So on average, Barnhart was 33.5 years when the books got published. And so on and so on and so on. So remember, typically speaking, you should be careful about the level of aggregation, especially if it's a sum, because if you're summing over multiple things, those numbers can get really, really out of whack. So that's one piece of the puzzle here. We need to kind of leverage the built-in functions for dates, and there are many functions that allow us to deal with dates a little bit more consistently than we would if we were just kind of cobbling things together. The other situation, though, is when we have things that look like dates but aren't quite dates yet. So for instance, in checkouts, we have checkout month, but notice that this is currently stored as a number. So the date variables have the little calendar icon next to them, but this checkout month does not. So let's make a new, in fact, we can just do it right here. Let's make a new calculated field based on checkout month. So we're going to go here, and actually we'll go here. Create calculated field, and we're going to call this checkout date rather than checkout month. And what we want to do here is make a new date. So we can do that with date. Like we're going to convert whatever is in here to a date. And to do that, let's do it in like the American date format, month/day/year. And so for us, checkout month comes first. I'm going to do this wrong before I do it right. Month, and then I need to fill out the date string. So I need to go like, I'm going to assume that all the checkouts happen on the first of the month. I don't really know. I just have to make an assumption. And 2193 is the same year as everything else in the data set. Remember, this data set's from the future in 2193, and so everything else is there. So notice this calculation contains errors. Can't add integer and string values. So here I'm trying to add a string, but this thing is actually currently stored as a number, and so I need to convert this to a string. So if you haven't watched the video on working with strings, this is one of the things that we cover there. This is just converting this number, like the number 7, that would be July, converting the number 7 into the string, like the character in quotes 7. And I know that seems like a small difference, but type of variable is so critically important in data analytics that we have to really formally convert across, because everything that we do, not just in like simple things like this, but big things too, depends on the type of a variable. So it really is a big deal to convert things from the number 7 to the character 7. I know it seems silly, but it's really actually pretty fundamental. Okay, so now I can actually go through here and take a look. Like, let's actually run this thing. And now what this allows me to do, I'm going to go to a different sheet. What this allows me to do is if I make this my columns and do my checkouts as my rows, I can now so I could go down to month, that's great, but I can also like aggregate based on quarter, which is something I would not have been able to do if I left it as checkout month the number rather than checkout date the date. I get all of these functionalities for free, totally for free, because I've converted checkout date to an actual date rather than a number. So where possible, you should make sure that everything that represents a date is actually a date in Tableau, even if you have to convert it with this date syntax. And the reason being that you get so much functionality for free. So two things going on here. The first being, be careful when you're talking about sums or differences. Try to use the built-in functions when you're dealing with dates. And every time you have a field that represents a date but may not yet be stored as a date, be sure to clean those up as part of your data pre-processing step so you can leverage as much of the goodness from Tableau as possible.